Well, we'll just start with our normal boring admin bit, and then probably a few more people will be here by the time we're ready to go. So of course, the reason we do all of this admin each time is because it's recorded, and it just gives the background to anyone who might be joining us for the first time, although I do know that most of your names are all familiar, so thank you for coming back. So where we're at, this is lesson 7, so we've just gone over halfway, which is fantastic. This is the first part of equations, and we've just finished up with the 3 parts of algebra. So the general housekeeping stuff, you know, blah, blah, we can't do all the year 8 curriculum. We want to hit all the key points to make sure that you've got all the key concepts under your belt. They're all recorded, and the key point from this slide is really just the website that's there, so you can go and get access to these slides and the recordings. The recordings are really useful because there'll be extra questions that I don't necessarily get you to do today. You'll be able to go back over and do those. And you'll be able to re-watch the explanations in case some of them were a bit confusing. You can pause and go at your own pace. So that's why the recordings are great. Good morning, Zane. Good morning, Blah. We do use the chat on occasions. So you'll see in Zoom that there'll be a chat section. Generally, that chat will just point to chatting to one of us as the panelists. Don't be worried if you don't see the responses from other students. You're not alone. There are other people in the room. It's just less distracting if we don't have that enabled. But there is a Q&A section. I know most of you have found that already. Hi, Ron. How are you today? You can throw in the Q&A questions there, and Miss J might be able to handle them as we go through. And anything that's left over, we try and make sure we cover at the end. We don't want you leaving today with questions, you know, that you have unanswered. It's better to try and ask them, and they'll either be a simple one or we can go over some stuff again. So let's just quickly, we've got a few more that have joined. That's fantastic. I'm just going to open up the link for Pear Deck. So you're all familiar with this, of course. If you're watching the video, the Pear Deck won't work. The Pear Deck is for our online and interactive participants that we have in the room today. So you need to go to joinpd.com, and there is our code for today. So it's HAYLU. Hilarious avocados yield lovely umbrellas. That is our code for today. Avocados are good. That is a good theme to lead into our next question, Miss J.
Yeah.
Yeah, that's good. Okay, I'm going to move on to the next slide, but that's fine. People who come in late, I know Miss J will catch them up. So let's start the class. I'll just skip through those ones I've just talked about. Let's talk food. Something that has been on the minds of a lot of people at Mathspace since we've gone into lockdown is the sorts of foods that we used to enjoy. Maybe we're out, maybe they were takeaways, maybe they were things that we would cook but we can't cook now because we've run out of ingredients. So there's been a lot of talk about food. So each week, Miss J and I, we do a little slide about who we are, because we figure if we were in a classroom with you, we would all be getting to know you on some level. So I think now's the time to talk about food. I've been doing a lot of cooking recently. In fact, I do grow a lot of vegetables. You'll know that I live on a little farm, and at the moment I've got a lot of mushrooms. So I've been cooking mushroom risotto and mushroom stroganoff, roasted mushrooms. Yeah, lots of fun stuff like that. What about you, Miss J? How's your food going?
Yeah, we've been cooking a lot more, obviously, because we can't go out, and my son has been experimenting with a lot of sourdough, which seems to be a popular trend right now. So we've had bread, and more bread. But myself, I've been practicing trying to up my game with cooking things that we like to eat out, like stir fries and pastas and even homemade pizza. We've been doing homemade pizza crust. So, and some of the ones that we've done have been better than what we've had out. So maybe we'll be saving money, continue that even after the lockdown. Yeah.
Yeah, thanks, Alexia, for contributing to the conversation there. We've got a little interactive slide. So this is our first interactive. It helps people get used to this Pear Deck if you haven't used it before. It also helps us learn a little bit about you. So our question today is there any type of food or meal that you've been missing whilst you were in lockdown? So I suppose it's been a few months. Maybe you used to go and get Chinese takeaway or a nice Indian curry, or maybe you used to cook a lot and then all of a sudden, I don't know why, but then all of a sudden you couldn't buy flowers in the supermarket. It's been weeks since we've been able to buy flour, so we haven't been able to do any baking. So
sourdough.
There's a Pear Deck interactive there, so you just need to go in, and this one's a text response, so you just need to write in what your response is there, and then I'll just flip them up on the screen. Japanese, oh yes, Japanese, nice. Yeah, international food restaurants, Parmigiana, yeah, that's good. Did you, I can't see who did that. Oh, I forgot to mention to make sure you got your name of your animal when you logged into Pear Deck. Hopefully you did. Yeah, Chinese takeaways. Those sorts of things that are typically not something that you cook at home, I suppose, is the general theme there, isn't it? One of the things that I, like you, Miss J, that I've learnt since being in lockdown is sort of Thai curries, because I had never really cooked them before, but that was my favourite takeaway. So yeah, being able to learn how to cook those has been a learning curve, but it's so easy now, and I'm like, oh, I don't know if I'll go back and buy takeaway. Okay, so there's our responses. That's brilliant. So that just gives us an insight into you. Yes, they are making us hungry. And yeah, so now we'll be able to move on, and you'll have had a little bit of a play with Pear Deck. So where are we at? Last week we finished the last of the three parts of algebra. And that doesn't mean they're gone, because we're going to use all of those skills in equations that's coming up now. So if algebra was still a bit tricky for you, it's really worth going back over and spending, you know, an hour or two each week going back over the algebra questions, because it's not going to be time that's lost. It's really valuable to make sure that you consolidate that stuff. So all of our, you know, combining like terms, adding and subtracting, multiplying, dividing are all important skills to do equations. It would be quite hard to have success with equations if some of that algebra stuff is still a bit confusing to you. So just because the chapter's finished and the rest of the class has moved on, if you know that that's something you need to practice, please do. Just, you know, every year 8 book will have a section on algebra, and you'll need algebra now for the rest of high school. So really important groundwork that you can put in there to give yourself success later on. So this week, we're just looking at solving equations using algebraic manipulation. And then next week, we're going to be doing more complicated types of equations, I suppose. So we've just got 2 parts, or that should be part 2 of 2 for next week. We've got 2 parts, cover most of what we need for year 8 equations. As always, any videos are available at wootube.mathspace.co. They're mapped to our specific year 8 textbook, which I'll show you in a moment. So if you want specific lessons on each of those individual sections, then there's some videos there that can help you with that. What we're going to do today is not necessarily talk to all of those different sections in depth. Like I said, I'm going to make sure that we cover the key concepts, and I give you a few skills and tips and tricks, I suppose, to be successful. So here's our Mathspace textbook for year 8. We're in chapter 5 of equations. You see there's only 4 sections. I'm kind of covering the first 2 today, and we'll do 3 and 4 next week. The Mathspace textbook, if you don't have it, you don't have to have it. Every year 8 textbook will have a section on equations. It might be a whole chapter. It might just be part of the algebra chapter. So solving equations, we've got some theory, then there's a whole bank of questions here. If you do want to get access to this because you like the look of these questions, or you'd like to be able to do some questions interactively where you get the feedback step by step, you can just ask your teacher and they can get access for you. That would be absolutely okay. Okay, so on we go. Solving equations, the way I like to describe it, it's kind of like that tangled mess of headphones in your pockets and you want to listen to music and it's just this big mess, right? So solving equations is a bit like that. You know what your end goal is. You know that you need them untangled and you just work one step at a time, one twist at a time until you get them all untangled. And solving equations is just exactly like that. You work out what your next step is, you do that very next step. Sometimes it's a long process, sometimes it's just a couple of twists, but you do get there in the end. Take it step by step. So to explore this concept, what I want to do today is really get you to understand there's three sort of key skills that underpin solving equations. One is being able to understand, if you like, the order of operations, like what's happening to a number, what's happening to a letter. The other is being able to write that algebraically. And then thirdly is being able to untwine or untangle those things to be able to solve. So we're going to play a few rounds of what's my number. They are interactive slides. You just need to put in your final number. So here's the first one. I think of a number and I double it and then the answer is 24. So your question is, what is the number? What was the number I thought of? So that when I doubled it, the answer was 24. That's hopefully a fairly easy one for you. And because I'm going to use these same questions in a bit, I'm not going to put up all your answers, but I can see them on the screen. So when I turn sideways, I can see what all your responses are. So please do that. I can see that. Oh, fantastic. Everyone's got the correct answer. This week we've got peacock, a frog, a pig, a sheep, and what is that? Who is that other one? Can't tell. Maybe it's a sloth? Can't tell. So fantastic. You've all got the correct answer there. So let's move on to the next one. Okay. I'm going to think of a number. I'm going to add 10 and then I halve it. So there's two steps in this one. The answer is 11. What was the number that I started with? So there's a couple of steps. I thought of a number, I added 10, and I got some other answer in my head, and then I halved that, and the answer was 11. So we've got a couple of correct answers there, and I think someone's thinking because they're changing their answers constantly. Like I said, I'm going to solve them in a minute, so I'm not going to put up the answer straight away. There's still a couple of people who are thinking. We'll just give you another minute, a couple of more answers going in. Maybe it'll help to write it down so that you can then work backwards. That's kind of the key to one of my strategies today, is backward thinking. Who's left? Come on. Oh, yes, well done. Okay, we've got peacock and lion are in. Frog's got an answer in. Boar's got an answer in. Don't forget there's two steps. Now, what I can see on my screen here is that there are two common numbers that are being thrown up. One of them is the correct answer, and the other one is because you haven't done the last step. Okay, keep that in mind. Maybe write down what you thought your answer was to question 2, and you can reflect on that when we get to the solving bit in a little moment. Okay, here's the third one. I think of a number. This is a couple of steps here as well. And then I divide that by 3, and then I add 16, and the answer is 17. Have a think about that one. Think of a number. I divide that by 3, then I add 16. The answer is 17. So I would, if you've got a scrap piece of paper, write that down, put it into steps. Think about how to undo those steps, like untangle those earbuds, see how you go about it, trying to go backwards to decipher where I started. It's got a sneaky step in it because I've been saying, I think in every algebra lesson I said, this is the phrase I said, this will be a clue to one of the steps. Anything divided by itself is 1. I've been saying that a lot. So any number or any letter, when you divide it by itself, is 1. And that's it seems like an easy thing to say, and you sort of go, yeah, that makes sense. But that is a common mistake that gets made in equation solving, is being able to undo that particular step. And that step is in this question. Yes, well done. Lion and Boar are in. They've got the correct answer. Well done. We've got Peacock and Frog has locked some numbers in. I can see Frog's got the correct answer. The benefit here is if you know that you're Peacock, you're still not quite there. It gives you another chance to have a look at it and see if you can find your mistake. So I think of a number and I divide that by 3. And then when I add 16, the answer is 17. Okay, just another 30 seconds. Doesn't matter if you don't get it wrong. I'm not putting the answers on the screen. It's only you and I that's going to know. So. Okay, right. So let's have a look at about undoing these things now. So this was the first question that we did. It was the most simple one. It was a one-step problem. I think of a number and double it, and the answer is 24. So I'm going to write this out in a special way. I'm going to use just some boxes. I'm not going to use algebraic letters just yet. And I'm going to write it out as I kind of described what happened to the number. So I think of a number. Just imagine this empty box is the number, okay? So think of a number and I double it. So there's a lot of decoding that happens in equations. You need to know the language around double, triple, halving. You need to understand, multiplication and division and all the different ways that can be described. So I think of a number and I double it, and then the answer is 24. So we write that as equals 24. Okay, so when we're looking at how to undo these sorts of operations, well, in this case, it was a one-step problem. Everyone got the right answer there. And it really was just about understanding that one-step problem of what is this fact? What is this? In this case, it's a multiplication fact. What times 2 equals 24? Well, we know that that answer is 12. It's just a one-step process. What times 2 was 24? Okay, so that was a nice simple one. And I'm going to use the same process to set up the next question, okay? So, second one was, I think of a number, and then I add 10, which gave me some number, right? There was a step in there. I had to get that answer in my head. I had the number, I added 10. I've got some other number in my head now. And then I halve that. So a halve in maths is divide by 2. And the answer is 11 means equals 11. So that's the way we could write this out. Now to backtrack that, which is the strategy that this is called, it's called backtracking. To go backwards, we just need to do one step at a time. So I'm going to cover up that first bit because the first step I need to do is undo that last thing. What divided by 2 is 11. So it's a one-step thing. It's like knowing your multiplication or times tables or your division facts. What divided by 2 is 11? Well, we would know that's 22. And I reckon you'd all get that. The next step is, well, then what plus 10 is 2? Still, it's just a one-step problem. And you'll just notice we did that one-step thing a couple of times. We just did one step at a time. That's what I'm saying. It's just like untangling your headphones, just one twist at a time and you'll get there. So something plus 10 is 22. That gives us a 12. So the answer to this one was 12. Okay, question 3 was up just before. I think of a number, I divide it by 3 and then add 16. So we write this out our special way. I think of a number, I divide it by 3, I've got an answer. I add 16, and then the final answer is 17. Okay, so doing our backtracking, our one step at a time, cover up that first bit. I just ask myself, well, what plus 16 is 17? Well, we know that that is 1. Then my next step is, what divided by 3 is 1? And I gave you that clue, remember, that anything divided by itself is 1. So 3 divided by 3 is 1. So the answer to that one is 3. Okay, so this idea about just being able to unpack and do the step-by-steps, this is exactly what solving equations is, okay? So just being able to undo it. Okay, let's go crazy. Let's do this massive think of a number one step at a time. So what I want you to do is on your piece of paper or just in your head, we're going to work backwards from the answer. So over here at 28, we're going to work backwards one step at a time. So if you've got the answer to this one, you can just throw it in the chat for Miss J to see. Just going backwards one step at a time. You just got to imagine covering up all of these first slides. Oh, no, it is an interactive one. You can enter in your number. Okay, so work through that. There's 5 steps here. So you're just going to start by asking yourself, well, what divided by 2 is 28? What minus 7 equals that number? You're just going to go back one step at a time, each time just doing one thing. Just going to turn to the side and see your answers come in. Oopsie, sorry. Why did it do that? With my Let's Go Crazy screen. There we are. Sorry about that. You might need to put your responses in again. Don't know if it saves them. What do we go on? Frog's locked in an answer. The great thing about this too, and this is the truth for pretty much every equation, you can then put your number back in at the beginning, follow the steps, and see if it works out. See if it's the actual answer. Like, there's almost no way you can get it wrong because you can always check if the answer you've got is right. Yep, Boar's got an answer in. Lock it in, Eddie. See, Peacock's thinking. It's got think time. How are we going? Okay. So one step at a time, remember. So the first step is what divided by 2 is 28. How do you go backwards from that? What divided by 2 is 28? Okay, well done everyone who's got their answers logged in there. I'm going to keep moving on so I can work through this answer with you all. So you'll have a chance to keep working if you're still thinking about it. So here's our first step. Something divided by 2 is 28. So you need to understand that would be 56. Now this is where often in schools, the way that solving equations is approached is directly just with reverse operations. And so they probably would teach you directly here that the opposite of divide by 2 is times by 2. So you sort of go the other way. And that's exactly what's happening. But for some people, it's just more intuitive to think of it as, well, what divided by 2 is 28? It's obvious that that's 56. Okay, the next step is, well then, what minus 7 is 56? If I subtract 7 from a number, I get 56. So then, like using reverse operations, it must be 7 more than that. So you'd see that the answer was 63. Okay, the next one step is, well, what times 3 is 63? Now, it may be a bit beyond your normal, 12 by 12 times tables facts, but you can work that out. Something times 3 is 63. Yeah, 21. Okay, so we've got a couple of steps left. Something plus 3 is 21. What's that one step? 18. Yeah. And the very last step is, well, then what times 2 is 18? And the answer was 9. So that's the lot of steps. There's like 5 steps in that. The 1, 2, 3, 4, 5 boxes we had to fill in, and we just did it one step at a time. But here's the crazy thing. This is the equation that you just solved. If we were to write that out as an equation, you just solved this big, massive, monstrous equation. And you did it pretty simply. You just did it one step at a time as you move through. Now, the good thing is you don't actually have to solve equations that big in year 8. That is far bigger than you need to do. So if you did well at that one, and I know some of you did, you've nailed it. Like, you've got these step-by-steps done. That is a really big equation. You only have to solve equations with like 3 steps in year 8. So only 3 boxes, 3 little twists and turns to undo. And so that's what we're going to be looking at today, is equations that don't get this big, but equations that just go up to 3 steps. Okay, so still back looking at the first question that we looked at. One moment. Okay, so I think of a number. Our very first one was, I think of a number and I double it, and the answer is 24. And we've already done how to solve that. We've done the backtracking piece. We know that the answer is 12. But how do I write that as an equation using letters? So if my think of a number was a letter A instead of a box, how could I write that equation? How can you write an equation that is some number called A doubled equals 24? So this is what hopefully you've just thought of in your head. So you've got some number A, doubled it means times 2 equals 24. So that is the equation that we solved before. We just did it using our backtracking boxes because we were just thinking, well, what times 2 is 24? And the next step is just to add the algebraic level, just to add those letters on top. So if this was the equation that we wanted to solve, 2a equals 24, you're still asking yourself the same question. What times 2 is 24? It's still exactly the same as this. They are the same, different ways of thinking about it. And some people can work between these two types of representations easily. So in this particular case, if we wanted to solve it algebraically, we would do something like use our reverse operations, which is what I said is often told as the sort of the method for solving equations. What's happening to the A? Well, the A is being multiplied by 2. So how do we undo that? Well, to undo it and go the other way, this is going this way, to go the other way, you do the opposite operation, which is to divide by 2. So algebraically, we would write this as 24 divided by 2, where A equals 12. Okay, now we already did that. And sometimes writing things out algebraically makes it far more complicated than it needs to be. For all one-step problems like this, where it's just being multiplied by something, it's just being added to or subtracted from, I don't think, and I don't normally ask all my students to write out all of these steps for a one-step, because a one-step equation you should probably be able to see. But it does help if you wanted to practice putting all your working down so that you can tackle, more harder things, more complex things later on. So I'm just going to go over that one more time. It's a very basic one, but it's really important that we sort of understand the two types of representations here. This was our think of a number. We doubled it and the answer was 24. That's moving forward. The way we solved it was to work backwards. We thought, well, what is some number times 2 equals 24? And a way to think about that is using the reverse operation. What if our number represented was the letter A? Well, we would write that saying, well, I think of a number A and I times it by 2. And we know, because we've finished our algebra chapter, that when I have A times 2, I actually write that as 2A. So this is the original equation, and we've already looked at how to solve it. You solve it by going backwards, undoing what's being done to it. Okay, let's look at the second one, which was 2 steps. So this is a little bit more, I've got some practice for you for 1 step first. Okay, so that was the 1-step one. I've done that. We write that as 2a equals 24. Oh, no, I changed my order. We are going to go through how to write these out. Sorry. Okay, so now this is the second one. So this is a 2-step. So there's 2 steps because there's 2 boxes here to solve. And 2 steps because to undo the algebra, there's sort of 2 steps required. So have a little think about how we would write this equation using the letter B as the box, because that's the original think of a number. So how could I write this using algebra? So I think of the number, in this case it's the letter B, and then I add 10. So that step's easy. I have B plus 10. Think of a number and add 10. The next step says then halve it. So I have to halve this whole thing. In our backtracking boxes, we could see, well, I had B plus 10. I would work that out in my head. I would know what that is. And then I divide it by 2. So all of this needs to be divided by 2. So in algebra, we write that like this. So the whole B plus 10, whatever that works out to be, divided by 2. You could add brackets there. That's fine. It means the same thing. Do all of that first, then divide it by 2. And then our answer is 11. Okay. So let me go over that again. I think of a number. We're going to call it B. I add 10 to it. Then halve that whole thing, all of that, whatever that adds up to be, I halve it. And then that answer is 11. When we do it in our backtracking boxes, we were working forwards, and then to backtrack, we had to work backwards. And when we were backtracking, we were undoing those operations. We were thinking, well, what divided by 2 is 11? And the way we did that is we went, oh, well, that must be 22, because the opposite of dividing is times. And so then I get this answer. This middle step is 22. What plus 10 is 22? Well, the opposite operation, or the inverse or reverse operation for addition, is subtraction. So then I would say, well, what is 22 minus 10? And the answer is 12. We can always, remember in algebra we did that section on substitution? We can always do that, substitute back in. So we go, okay, well, if the original number was 12, and then I add 10, well, that gives me the number 22 in the box. And if I divide that by 2, I do get 11. So you can always check your answer. Okay, so that one's pretty tricky because we had the whole thing divided by 2. Let's look at doing exactly that question. B plus 10 all over 2 divided by 11. Now we've already seen how to backtrack it, and we looked at reverse operations. So going backwards here, we would times by 2. Going backwards there, we subtracted 10. That's exactly what happens when we do this algebraically. We have B plus 10. At the moment, it's being divided by 2. We have to undo that. So that would be times it by 2. And that gives us on this side 22. You'll see that that is exactly the number that we get in our one-step box. B plus 10 is now 22. To undo that, we would go, well, now subtract 10 from both sides. So you might write it out like this. Subtract 10 from both sides, because that's this inverse operation. That cancels that out. But really, it's because we're asking ourselves what's happening up here in the boxes. What plus 10 is 22? That's what's happening here. That's what B plus 10 equals 22 is solving. What plus 10 is 22. So it's a one-step equation again. And then you'll work out that the answer for B is 12. Okay, so I'm going to write out the full algebra stuff now. For that particular question. So this was solving the equation B plus 10 divided by 2 equals 11. We'll write it out like this. B plus 10 over 2 times 2 equals 11 times 2. You've probably heard your teachers say a lot, whatever you do to one side, do to the other side. Do the same to both sides. Like it's very common things to hear in a classroom when it comes to equations. What we're doing here is reversing that operation. Okay, so we end up with B plus 10 equals 22. Something plus 10 is 22. We could write it like this. Some teachers might say, move the 10 to the other side. That's the same as just isolating the B. You know, we're subtracting the 10 from both sides, and that gives us B equals 12. So I've just done that same problem about 4 different ways. I've tried to use as much of the language as might be familiar to you from the teachers that you're used to, and trying to connect it to this idea that it's just doing one step at a time, untangling these strings. Okay, let's have a look at the third one. It was a little bit more complicated one. Now we're going to use the letter M. Okay, so on your scrap piece of paper there in front of you, try and write this one out using the letter M. So that means that's the initial number. Think of a number, and I'm going to call this letter N, and I'm going to do these things to it. How can I write this using algebra? So the idea is that we have M. In algebra, division is usually shown as a fraction. So I divide it by 3. We'll work out whatever that fraction is, or whatever that division is, and then I will add 16 to it, and the answer is 17. Okay, so that's how we write that using algebra. Now we can also, just move this down, we can also connect that to our backtracking boxes, okay? So when we were doing it before, we were doing one step at a time. We asked ourselves, what plus 16 equals 17? So the reverse operation to plus 16 is minus 16, okay? And we would get that answer, 17 minus 16 was 1. So that's it. To see what that looks like with our algebra, we do the same thing. And I've run out of room on my screen. Move these again. Let's put that up here. Okay, so using our algebra, what we just did was m over 3. We said, well, what minus takes the 16 from both sides. Let's do this subtract 16 business. So we end up with 17 minus 16, where m over 3 equals 1. And that's what we've got here. Something divided by 3 equals 1, because we've got our 1 step left over. Okay, reversing this operation. The opposite of divide 3 is times 3. So we're going to go, well, what is 1 times 3? And the answer is 3. And that's because when we do it algebraically, we get what is 1 times 3, because the opposite of divide 3 is times 3. And we get the answer is 3. Yeah, that was good. So I see some people threw in the chat there, their equation. Well done. Okay, we've got some your turns coming up. See if you can connect these ideas together. So this is my turn. I'm just going to do this one, and then I've got a screen for you to choose some questions to do yourself. So this is a one-step equation. There's one thing that's happening. I'm going to do it 2 ways. I'm going to do it using our boxes, and I'm going to do it using formal algebra. So boxes first. Here's my letter K. I don't know what it is. What's happening to the K? Well, at the moment, it's being times by 4. And then the answer is 32. So to go backwards from that, I just asked myself, what times 4 is 32? And I know that answer is 8, because 8 fours are 32. The other way to think about it is, how do I undo the operation of times 4? It's divided by 4. And then I just say to myself, well, what is 32 divided by 4? And the answer is 8. So in this case, we can see that the value of K is 8. Let's do this now using formal algebra. 4K equals 32. The opposite of times 4 is divide 4. You might hear someone say, isolate the K. You want to get K by itself. And to do that, we need to get rid of this 4. So we're going to divide both sides by 4. The reason we do that is because anything divided by itself is 1, and that cancels each other out, which leaves us with just the K equals 32 divided by 4. You'll see here that's exactly what we did over here. K is 32 divided by 4. We know that K is 8. So that is exactly the same equation being solved 2 different ways. One just using formal algebra, and one using what we call backtracking. There's absolutely no difference to this. You can do it either way. Okay, so now it's your turn. I'm going to move on to the next screen. There's 3 possible, these are all one-step equations. One is a multiply. The next one has just an addition, and the next one just has a subtraction. You can choose whichever one you like, and you can throw it in the little box there. So it doesn't matter which one. Okay, I'll just move the mic. Thanks, Fergus. So it doesn't matter which one, just pick one of them. They're just one-step equations. I also don't mind if you want to solve them using your formal algebra, or if you want to solve them using the backtracking boxes. So it doesn't matter which one. And they're all one step. You know, one step just means you can just ask yourself, what plus 16 is 25? Or what subtract 25 is 14? Just getting my notepad. So have a go. There's a couple of answers going in, which is fantastic. Have a look. Who's that one? Have a look again, Peacock, at your answer there. If I have a number and I subtract 25 and the answer is 14, then my original number must be bigger than 25 because my answer is positive. Okay, we've got some good answers in. All right, so I'm going to just quickly work through. What's the time? Yeah, I think we're doing all right. I'll just quickly do a couple of these so you can see. I'm going to do the first one using normal algebra. So here we have 5s equals 25. Can everyone see my screen okay? So we've got 5s equals 25. So we're going to undo the times 5, which means divide both sides by 5. And we get that s is 5. So a few people did that one and they got that one correct. Well done. I'm going to do the next one. I'm going to do it using our backtracking boxes. Something plus 16 equals 25. So to go back the other way, I need to undo that operation. I can do 25 minus 16, which gives me the answer of 9. So in this case, t equals 9. For m minus 25 is 14. I'm going to do that one using algebra. M minus 25 equals 14. I have to do the reverse operations. So this is being minus 25. So the reverse operation is to plus 25 to both sides. That gives me m equals 39. Okay, so just check your work there. A couple of people did really well. That's fantastic. A couple of people might need to just practice looking at the reverse operations. Okay, I'm going to do, now this is called a two-step equation. I'm going to do this one 2 ways for you, and then there'll be a slide for your turn, okay? So 2 steps because there'll be 2 separate things that we do to undo this tangle. So we're going to look at it first from the what's my number idea. So starting with the letter C, what's happening to the letter C? Well, the first thing that's happening is I am adding 8 to it. So this is why it's really important to know your order of operations. So I'm going to have that C and I'm going to add 8. I'll get some answer in my head. And then what's happening is we're dividing that whole thing by 4. And then we see that the answer is 20. So to undo that one step at a time, we just ask ourselves, okay, well, what divided by 4 is 20? Or going the other way, 20 times 4. Can you see that? Going the other way, we're going to reverse the operation. So we do 20 times 4, so we get 80. Now I ask myself, well, what plus 8 is 80? Well, to reverse that, we do a minus 8. 80 minus 8 is 72. We okay with that? We can also check. We can put 72 back in. 72 plus 8 is 80, divided by 4 is 20. Good one. Okay, I'm going to do it now using algebra. Over this side, C plus 8 equals all over 4. So we have to undo. So you need to know your order of operations and you need to ask yourself, what is the last thing that's being done? Well, in this case, the last thing that's being done is this divide by 4. So I'm going to times both sides by 4. Just notate it like that for you. I do both sides by 4. And then I'm going to have C plus 8 equals 20 times 4 is 80. That was our middle step here, you'll see that. Now I'm going to reverse this step. This is being plus 8, so now I'm going to subtract 8 from both sides. So C equals 80 minus 8, which is 72. Yeah, well done, Josephine. So you can see the same on both sides. One just using our backtracking boxes, one at a step at a time, and up here using formal algebra. Okay, now it's your turn. There are 3 questions on this next slide. You can choose any one of those. These are all 2-step equations. There's 2 different things. In this first case, we have what's happening. Let's talk through that first, actually, because that'll get everyone started. Here's the B. What's happening to the B? Well, I'm adding 7 and then multiplying the whole thing by 2. So in this case, I'm adding 7 and then multiplying the whole thing by 2. Okay, in this next one, what's happening to the K? What's the first thing that's happening? Well, I'm timesing it by 4 and then I'm subtracting 13. Okay, and this third one, what's happening to the F? Well, the first thing is I'm dividing it by 5 and then I'm adding 8. So there's the starting point. You just need to reverse one of those. You'll see that they're all 2 steps. Uh-oh. There we are. Are we going? Yep. Peacock's solving it a different way too. They're using expansion that we learned in our algebra skills. So that's really good. Well done. So make sure, Peacock, that now you solve that. So you've expanded it. Now you still need to find what B is. You still want to solve for what was the number that I started with? Okay, some people still working through, that's fine. I'm just going to throw the answers up because I think it's important that you know if you're right or wrong. So this first one, we could just backtrack these boxes. Something times 2 is 24, that would be 12. Something plus 7 is 12, that would be 5. So in this case, B is 5. I can do that using algebra. So if you wanted to check your algebra working, we get some B plus 7 equals, if I divide both sides by 2, I get 12 here, C is 12. And then I subtract 7 from both sides, so I get 5, same. Okay, using the boxes, something minus 13 is 15, well that will be 28 because when you go the other way, you add 13. Something times 4 is 28, well that is 7, so I can see here that K is 7. The other way to do that using algebra, 4K minus 13 equals 15. I add 13 to both sides. I get 4K is 28. I divide both sides by 4. I get K equals 7. And finally, using the boxes, A is 11, that's 3. Something divided by 5 is 3, that would be 15. So I can see here that F is 15. Or I can do that using algebra. I'm going to subtract 8 from both sides first. And then I'm going to times both sides by 5. Same answers. In a lot of ways, I prefer boxes. Because it just keeps it down to one step. I'm showing all the same amount of work. I'm showing exactly the same sort of thinking. I'm reversing the operations, but I seem to be able to do it all on one line. The problem is, though, is that method only works when the letter appears in one place. So we're a bit restricted there, but we're certainly getting there. And these algebraic skills are important, definitely, for when we get to harder, more complicated equations. But certainly when we're looking at this initial idea about practicing reverse operations, I see no problem in practicing using our boxes, our backtracking method. Okay, well done, everybody. So that's two-step equations. All of them had two boxes. There were two things to undo. The last thing is three-step. So this is as hard as the equations get in year 8, is three-step equations. So there'll be 3 boxes to deal with. So here we go. Let's do it in boxes first. We're going to ask ourselves, what's happening to the letter, in this case, D? The first thing that's happening is I would have to evaluate the brackets. So I'm going to minus the 6. Once I've evaluated the brackets, I'm then going to multiply it by 2. Once I've got this whole piece worked out, the last thing I would do would be to add the 12. And then my answer is 10. Okay, so there's my setup. I've done all of thinking in advance. In the backtracking boxes, I've sort of done that unraveling. So now all I need to do is go backwards. Something plus 12 is 10. Well, that must be 2. Something times 2 is 2. Well, that must be 1. And something minus 6 is 1. That must be 7. So then we can check it. We can put 7 in here. 7 minus 6 is 1. Well, what have I done wrong? Oh, forgot a negative. Did you all see that? Did you see that? That's a common mistake. I've done it just like the best of you. Let's go back. Something plus 12 is 10. Must be negative 2. Don't forget the negatives. I did that. Look at that. Okay, something times 2 is negative 2. Must be negative 1. Something minus 6 is minus 1. What do we get there? 5. Okay, so now when I put in the 5, I should get the right answers. That's the benefit of checking, is that you found out that you've made a mistake. 5 minus 6 is minus 1, times it by 2 is minus 2, 12 minus 2 is 10. Okay, algebraically, let's see what that looks like. So it's going to be a lot more lines. I'll have to try and write small. So we've got 2d minus 6 plus 12 equals 10. So we need to undo the operations, just like here where the first thing we undid was the 12. It's the same thing here. We need to get rid of this loose number over the other side. Subtract 12 from both sides. 2d minus 6 equals 10 minus 12 is minus 2. That's the same answer we got here. You'll notice that each line of our algebraic working will match to one of our boxes. Now the next thing I need to do is get rid of this 2 at the front, divide both sides by 2. I end up with d minus 6 equals negative 1. Again, it matches up with one of our boxes. Now I'm going to add 6 to both sides. D equals 5. Again, matches up with one of our boxes. Okay, all the same thinking is involved in either process. Okay, now it's your turn. 3-step equations. Remember, this is as hard as they get in year 8, having to unravel 3 steps. Watch for negatives. You'll see it's easy to do. I got tripped up on the last example. So you're going to pick one of those, throw it in the working out. This gives me a chance to see how you're going. So you can pick one, you can do all 3. Whilst you make a start, if you need a bit of a pointer, I'm going to make a start setting up some boxes on the screen. So we have here some number minus 5, times that by 2, and then I add 1. So if you wanted to kickstart with that first question, you could just backtrack those first boxes. We've got some number plus 4 divided by 2 plus 5, 13. Some number times 5 plus 7 divided by 4 equals 8. So there's a head start for anyone who was looking for a bit of a starting point. Just check the time. Oh yeah, we're doing quite well. So just take your time, one step at a time, unravel those equations. Lion's been distracted. At this point, I just imagine, Lion, that at this point I've walked over to your desk to ask you how I can help. There's 3 starting points on the screen, Lion, so you might be able to start there. Pick one of those and just backtrack the boxes. Yep, Peacock's on the right track. Okay, I'm going to keep going. So if you need to see some more starting points, then you can turn and watch the screen. So undoing this first equation, I ask myself, what plus 1 is 15? In that case, the answer is 14. My next step is what times 2 is 14? The answer is 7. And then the last step is what minus 5 is 7, and the answer is 12. So in this case, H is 12. If I were to do that using algebra, it would look like this. H minus 5 times 2 plus 1 equals 15. Subtract 1 from both sides. I am left with 14. That was the first box. The next step is to divide 2 on both sides. Leaves me with 7. That was my second box. The last step is to add 5 to both sides. And my answer is 12. Okay, some people attempted the second one. So let's do the boxes first. Something plus 5 is 13, that's 8. Something divided by 2 is 8, that's 16. And something plus 4 is 16, that's 12. So in this case, M is 12. Algebraically, let's see what that looks like. M plus 4 over 2 plus 5 equals 13. So first thing we're going to do is subtract 5 from both sides. All this stays the same, leaves me with 8. That was our first box. Now I'm going to multiply both sides by 2. Gives me 16. That's the second box. Now I'm going to subtract 4 from both sides, get 12, and that was our final answer. And then the very last question was, something divided by 4 is 8, well, that would be 32. Something plus 7 is 32, that would be 25. And something times 5 is 25, that would be 5. Some people attempted that one, so that's good. And then we'll just see what the algebraic working for that looks like. 5m plus 7 over 4 equals 8. Times both sides by 4. Gives me 5m plus 7 is 32. Subtract 7 from both sides. 5m is 25. That was our little box in the middle. And then divide both sides by 5. Gives me 5. That was our final answer. So we've learned today a couple of, hopefully you've seen a new thing. You've been able to make a new connection to solving problems and this whole idea of it's just one step at a time. Hopefully you've made the connection about how important that order of operations is, because if you do them in the wrong, you've tried to unravel, a piece of the headphone before you're ready, you'll end up with a bigger knot. So we want to make sure that we're doing things in the right order, and knowing the order of operations is really important. So I'm going to leave you with this challenge for next week. This is harder than you need to do in year 8. So if you just want to stick to as hard as you need to get, then you go back to your year 8 book, you just do some 3-step equations. This is just like that one that we did at the beginning, now let's go crazy question, but I think you can do it because it's just one step at a time. So I've started you off here. I've shown you that the first step is going to be unraveling this number, something times 3. You just got to look at where this x is, and you just ask yourself, well, what's the order of operations? What's happening to this x? And the first thing that's happening to the x is the times by 3 here. And then all you need to do is work out what each of these steps are, and then do them one step at a time backwards. So I'm going to leave you with that challenge. Write it down, have a go. We'll start next lesson with that challenge question. I'll say again, it is a challenge. It's harder than you need to know, but I don't think it's beyond you. I think knowing now how we can solve these things with boxes, I think you can all do it. I think you've all showing me screens that you can do it. Lines showing me that they can draw rainbows. I think it's been a great day. I'll just check with Miss Jane if there's any questions in the Q&A.
Nope, all good.
Nothing today. Okay, well, now's your chance, everybody. If you do have some final questions before you go, please hang around, throw them in the chat or throw them in the QA. Happy to talk to you. There's not many, so I can talk to you specifically if you have a specific question. Other than that, it's been great to have you all back. Hopefully the people that we're missing today will still catch up on the video. So thank you, everybody.